Our last speaker is Janie. I think she's from Canada, correct? And she's going to speak about anticipating pathways and timing for cyanobacteria breakthrough at a two-lake bank filtration site via environmental tracers. Thank you, Janie.
That's correct. Okay, let's start. So good afternoon, everyone. My name is Janie, and I'm from Montreal, for the one who knows where this is. And I'm a PhD student at Polytechnique Montréal, and today I'm going to talk about anticipating pathways for cyanobacteria breakthrough, which is part of the work I'm doing at this two-lake bank filtration system. So, all right. The starting point of this work was originated from a paper published in 2016 by Pazuki and his collaborators. They actually demonstrated the passage of cyanobacteria cells at the same study site we have, and they highlighted the importance of having a detailed monitoring program to prevent for future potential breakthroughs of cyanobacteria. So being aware of that, we thought it was important to look at the dynamics of the lake that are contributing to the bank filtration system. And with this dynamic understood, it would maybe help designing the monitoring program or maybe help for future operational decision making. So before diving into the actual results, let's take a moment to put the context here. We have some stratified lake because we are in a seasonal climate, and throughout summer, is it working? No. Over here. There are some, where is it? Well, anyway. We have increase of temperature at the top of the lake, while temperatures are staying quite low in the bottom. And that such context can result in the development of different cyanobacterial or any microbial communities at various depths into a lake. But at the end of the summer, most lake would undergo a turnover or mixing of the water column, and that may produce some new bacterial blooms that were not there before or just in few quantity. So being, yeah. And with that in mind, we thought looking at the origin of the pump water and the timing of the turnover to prevent future cyanobacterial breakthrough. And so here is the result. The first step was to obviously identify the period of the turnover processes at the lakes. So today I'm presenting to you a graph here of the time series of the temperatures at different depths into the lake. Behind this yellow-orange shape, you see that the temperatures are increasing throughout summer for the first 4 meters, while the bottom of the lake is relatively constant. And between mid-October to mid-November, which is depicted by this gray rectangle here, we see an homogenization of the temperatures in the water column. Other tracers, such as electrical conductivity or even a stable isotope of water, are also pointing in the same direction. So with that in mind, we looked after at the same tracers, but in the bank filtrate, to see if we can trace this pre and post turnover water types. And what we found is quite interesting. On this graph, you have the evolution of the temperature at a observation well just 10 meters from the lake in black. And you also have the stable isotope of water, namely oxygen 18, in red. And what I want to show you with this is that before the turnover period, the stable isotope of water signature was really similar to that of the bottom of the lake, and that after the turnover process, we are reaching a signature similar to the lake average. So it is fairly easy to track the pre and post water types at this bank filtration system. And yeah, we can use it for management. And so with these results, we are now trying to anticipate for future potential turnover-driven cyanobacterial blooms, and we could also use this for adaptation for pumping strategies to the lake dynamics. For example, if we pump all the available wells at more reduced pumping rates, we could reduce the mean flow velocity or even increase the residence time. So this is for me today, and thank you for your attention.
Thank you, Janie.
Thanks.
Very interesting. We have time for some questions. One in the back.
Maybe I missed the point, but it's also a problem for the drinking water production. If you have these cyanobacteria in the abstraction well, or is it the focus more on the scientific interest that you want to know the turnover and these things?
Okay, if I understand correct, you're asking if we do find some cyanobacterial cells at the pumping wells?
Yeah.
Yes, there are some.
Is this the problem for the drinking water production, or is it a factor to consider?
It could be affecting it, so that's why we're studying it, yeah.
Okay.
But for the moment, we, well, the other research group didn't find any toxins, so this
Okay.
is the important thing, yeah. The depth of the lake, yeah, of course, I didn't mention it, thank you for asking. They are between 15 meters and 20 meter deep, sorry.
Thank you.
They are artificial lakes.
Artificial lakes. So
Yeah, made out of sand exploitation activities. Yeah,
Okay, thanks.
thank you.
Thank you very much, Janie. Appreciate all the speakers sticking to the time schedule. Just out of curiosity, how many people here enjoy these flash sessions? I mean, are you getting something out of it? Or because there's some reasons why you might not like it because there's not a lot of detail, but I'm actually finding them to be quite useful. Good. Okay. Thank you. I think the next session starts right now.